Assalamualaikum and good morning. Thank you to respected panel. My name is Mama Aiman. Today, I will present my final year project entitled The Study of Hardness Characterization on a TC Heat Treatment Thermoform Aluminum Alloy Composite. Recently, demand of ALCNT have increased excessively due to the high aspect ratio, high thermal conductivity, and great mechanical strength. In 1970, semi-solid metal processing have been introduced in order to process between solid and liquid phase. Thermoforming is one of the methods other than recasting which have been introduced. There are three parameters in fabricating ALCNT composite with high hardness value, which are content of multi-wall carbon nanotube, stirring time, and lastly, heat treatment. Heat treatment is a process involved in obtaining desired hardness characteristic, which will be our main focus in our study. Problem statement. ALCNT composite have been widely applied in industries, which resulting the importance of finding out the highest hardness characterization. There are various factors that can affect the hardness characterization, which are mixing process, mixing technique, amount of reinforced material, and post-processing method such as thermoforming and heat treatment. Our study shall investigate on the hardness characteristic obtained after thermoform ALCNT going through TC heat treatment. There are two main reasons why this study have been carried out. First is to characterize the hardness characteristic of thermoform ALCNT composite. Second, to analyze the hardness value of TC heat treatment on ALCNT composite. However, the study is limited to the scope of this project whereby it is limited to four components, which are material, process, heat treatment, and machine. There are two materials being used in this study, which are aluminum alloy, or to be precise, A356 alloy and carbon nanotube composite. The composite are going through the thermoforming process by way of mechanical stirring method, and later the A356 undergone TC heat treatment process. The study involved two machines in major, which are thermoforming machine to conduct thermoforming process and viscous machine in testing the hardness value. Looking forward to Chapter 2, the study could not be complete without referring to the previous studies and research conducted by the other experts. Most of this research were carried out by referring to these main four articles, which are articles entitled A356 Aluminium and Application, Carbon Nanotube and its Application, an overview of semi-solid metal processing, and optimization of mechanical steel casting parameter for fabrication of carbon nanotube aluminum alloy composite through Taguchi method. As you can see, this is the flowchart of our study in making sure that the project is being carried out accordingly. The processes involve 6 steps of processes. In completing this study, there are 6 processes that have been carried out, namely sample preparation, mixing, casting, thermoforming, heat treatment, and hardness testing. As you can see in the picture, uh, first during the material preparation, A356 block were cut into slice using bandsaw machine. Then, the A356 were weighed 400 gram to produce 2 billet of sample, while for magnesium and carbon nanotube were weighed at 0.5 weight percentage, 0.7 weight percentage, and 1.0 weight percentage by using weighing machine. The sample were made at aluminium melting point of 700 degrees Celsius with portable melting furnace. Thus, multi-wall carbon nanotubes powder and magnesium flakes were mixed together and wrapped with aluminum foil before immersed into the A35C alloy by using a plunger. The content of multi-wall carbon nanotubes were involved 0.5 weight percentage and 1.0 weight percentage respectively, and 0.5 weight percentage and 0.75 weight percentage of magnesium. Mechanical stirrer were turned at a maximum speed of 500 rpm to stir the mixer for 10 minutes. The specimen have been continued with the thermoforming process. This figure represents the thermoforming setup. A bar of cylindrical specimen were cut into suitable slot length and reheat into semi-solid state to be formed in the die. In this process, the specimen were heated by a high-frequency induction coil NK-type thermocouple was using to control the heating temperature, which locate 5 mm from the top of the slab. The thermoforming process was carried out by using a hydraulic cylinder press after the thermocouple was removed from the specimen. After that, the part were heat treated with solution heat treatment at 540 degrees Celsius for 8 hours by using Novatherm furnace as shown. Hence, the solution heat treated part was quenched in room temperature at 27 degrees Celsius. After going through the process mentioned earlier, the result shows the sample to have the highest hardness value of 106 M4. The hardness value is obtained by way of applying the optimum parameter as per stipulate in article written by Dr. Hanizam. The other three samples were prepared in order to make comparison between the non-optimum parameter and optimum parameter. This proves that heat treatment with optimum parameter provide the best result of hardness value. Finally, we can conclude that according to the analysis carried out, the heat treatment was the major factor that influenced the improvement in the hardness value of the composite, followed by carbon nanotube contents. The stirring time show the least effect on both properties of the composite. That's all from me. Thank you.